When we were calculating expected value and expected utility, we were relying on our knowledge of the probabilities of each of the outcomes of a decision. But we don't always know those chances. In those circumstances, we're going to need different rules to guide our choices. That will be the focus of this lesson. We're going to start by distinguishing decisions under risk from decisions under ignorance. And then we're going to look at 4 rules for making rational decisions under ignorance: dominance, maximax, maxi-min, and the principle of insufficient reason. In general, decision theory helps us make reasonable decisions when the outcomes of our actions are uncertain. But they can be uncertain in 2 slightly different ways. So one kind of decision is the decision under risk. That's where we know the probability of each possible outcome, and we use that knowledge when we make our choice. That's what's going on when we use expected value or expected utility and compare the expected value or utility of our different choices, maximizing that value. However, we don't always know the chances of each outcome, or we don't have a way of reasonably estimating them. Decisions in those circumstances where we don't know the probabilities are called decisions under ignorance. In these cases, each outcome has a value or utility, but we can't calculate the expected value or utility of each choice because we don't know the probabilities. So in decisions under ignorance, we can't compare expected utilities to figure out which choice is best. We need a different way. To emphasize, decisions under ignorance are defined by 2 features. You know what all the possible outcomes are, but you don't know the probabilities of those outcomes. So the overall structure of the decisions under ignorance is the same as the ones we're familiar with, the decisions under risk. We choose among acts that lead to different outcomes depending on the states of the world. To represent decisions under ignorance, we can continue to use decision matrices, only now the outcomes will only have utilities or values, but not probabilities. So what we'll look at now is several rules that can guide us to reasonable decisions when we're ignorant of the probabilities of the outcomes. We've actually already covered one such rule. That was dominance. Recall that this rule told us that one choice dominates another when it has about This rule told us that one choice dominates another. Recall that this rule told us that one choice dominates another when it has a better outcome, or one that is at least as good, no matter what happens. So looking at the decision matrix, the dominant choice has a better or equally good outcome in every column. That means we don't need to rely on the probabilities. We only have to look at the value or utility of the outcomes, because there'll be one choice that will always have the better outcomes. In the decision represented by this schema of a decision matrix we have in the middle here, choice 1 would dominate choice 2 if outcome 1 was better than outcome 3 and outcome 2 was better than outcome 4. Both of those have to be the case. Dominance also allows us to recognize that when there are multiple actions, even when there's no best one, we can sometimes rule out what are called dominated choices. Those are the ones whose outcomes are worse than any others, no matter what happens. So dominated actions are irrational. They should always be ruled out. They should never be the one that you choose. Let's apply dominance to an example. Imagine you have some illness that's imminently terminal. A doctor offers to perform some untested procedure that they think could save your life. But if it fails, you won't survive. Because the procedure's untested, there's no way of knowing your chances of surviving it. So we can't estimate the probabilities of the outcomes. So you have to decide to either get the procedure or not, when either the procedure will succeed or it will fail. If you get the procedure and it succeeds, you get to live a little while longer. But the outcomes of the procedure failing, that will always be death, because either you'll die of the procedure or you are going to die anyway. But if the procedure was successful and you don't get it, you would end up still dying. So since there's some chance that the procedure succeeds and you get to live longer, the choice to get the procedure dominates the choice not to get it. There's no way that things that could turn out that makes getting the procedure worse than not getting it. Now, dominance is a very valuable rule when you can apply it. But often we have to choose between actions that could turn out better if things go one way and worse if they go another. So we need rules that allow us to structure our reasoning about why to choose one option over another in those kinds of circumstances. The first rule we'll look at is maximax. When making a decision under ignorance, this rule tells us to choose the act that maximizes your maximal value obtainable from some outcome. So you choose the act that has the chance of leading to your best outcome. Now, like each of the rules we'll look at going forward, there are upsides of being guided by maximax as well as downsides. So the benefit of this rule is you get a chance of getting your best outcome. The potential cost, though, is that your best outcome may not be worth the risk of getting your worst outcome. Let's see what that means in terms of an example. Imagine you're considering investing a quarter of your savings into a startup because you've seen a few friends make a small fortune from doing so. The following decision matrix represents the possible outcomes and their utilities for you. Remember that we've structured our utility scale so that in general, like the probability scale, it ranges from 0 to 1, where 0 is your worst outcome and 1 is your best outcome. So if you invest and the startup succeeds, you'll be happy making a lot of money from your investment. So we'll give that a utility of 0.9. But if it fails, you'll be quite miserable from losing a substantial portion of your savings. So let's say the utility of that outcome is 0.1. Now, if you don't invest in the startup and it succeeds, you'll feel a little bit of regret. Let's give that a utility of 0.3. And if you don't invest and the startup fails, you'll get some relief. That can have a utility of 0.6. Maximax tells us to invest in the startup. That's because our best outcome can occur if we make the choice to invest. Our best outcome has a utility of 0.9. The downside here, though, is that if we invest in the startup, we also are at risk of landing with our worst outcome. And that risk may not be worth it to you. Our next rule tries to guide us when we feel compelled to avoid those kinds of risks. It's called maxi-min. And it tells us when we're making a decision under ignorance, choose the act that maximizes your minimum value obtainable from an outcome. In other words, choose the act whose worst outcome is better than the worst outcome of any other act. The difference between maximax and maximin, then, is that maximax tells us to focus on our best outcome for each choice, while maximin tells us to focus on our worst outcome for each choice. In terms of the pros and cons of this rule, benefit, you might get to avoid the risk. You might get to avoid your absolute worst outcome. The downside is that may mean losing a chance at your best option. So let's look at that investment example again and contrast the guidance Maxi-Min offers to the guidance Maxi-Max gave us. So unlike with Maxi-Max, the Maxi-Min rule tells us not to invest in the startup. That's because the worst outcome of investing, that utility of 0.1, when the startup fails, is worse than the worst outcome of not investing, that 0.3 when the startup succeeds and you feel some regret. The benefit of this is avoiding your worst outcome, that loss of your savings. The downside of this choice, however, is that we do end up losing our chance at the best outcome, making a fortune from the success of the startup. With Maxi-Max and Maxi-Min, you might suspect that some outcomes are more likely than others, even if you don't have a clear sense of how to assign any probabilities to them. But for outcomes where you have no reason to think that any outcome is more likely than any other, you might use the principle of insufficient reason. So this rule is a little different than the ones we've looked at so far, dominance, Maxi-Max, and Maxi-Min, because it actually tells us to assign probabilities. It says assign equal probability to each outcome. So that would be 1/2 for each outcome for 2 outcomes, 1/3 each for 3 outcomes. That's outcomes per choice. To determine what choice to make, we then actually get to use our expected value or expected utility formulas. Why? We've assigned probabilities to our outcomes. So that's the upside. We get to structure decisions under ignorance as decisions under risk and calculate expected value or utility. However, many decision theorists criticize this principle as being kind of arbitrary. And that's because just because we don't know that the probabilities of the outcomes are one thing or another, it doesn't mean that they're all the same, that they're all equally likely. Setting aside the reasons for skepticism about this rule, we still should know how to apply it. So let's again go to our investment example. There are 2 possible states, so 2 possible outcomes for each choice. We're going to assign each of the outcomes for each choice a probability of 1/2. With these newly assigned probabilities and the known utilities, represented there in the decision matrix, we can complete our expected utility calculations. So we have to calculate the expected utility of the choice invest and the expected utility of the choice don't invest, and see which one has a higher expected utility. And we get that expected utility by multiplying the utility of each outcome by its probability and adding those up for each choice. It turns out that the expected utility of investing is slightly higher at 0.5 than the expected utility of not investing at 0.45. So the principle of insufficient reason guides us to invest. But you might wonder, how likely is the startup to succeed? Maybe it only has a really small chance, and it doesn't make sense to think that the startup succeeding and the startup failing are equally likely. At this point, we've looked at 4 rules we could follow in making decisions under ignorance. And there are actually quite a few others we could have considered but didn't. Which rule do we use in making a rational decision under ignorance? Well, decision theorists agree that to be rational, you should at least avoid dominated decisions and make dominant ones. But beyond that, our guidance is less clear. Do we use maximax, maximin, the principle of insufficient reason? Well, researchers who study decisions actually can't agree on one rule that determines which decision is rational when making a decision under ignorance. Some think that different rules are appropriate in different circumstances, but they also can't agree on which rules go with which kinds of decisions. So this actually remains an area of active research. And with that, you should now be introduced to the idea of a decision under ignorance. And you've also been shown that there are some rules that you can follow, but no single clear rational action to pick in every such decision. Going forward, we're going to return to decisions under risk and show that, like with decisions under ignorance, there are some complications for figuring out which action is best.